Hello guys, how is it going? So today's video is going to be focused on setting up a JupyterHub on Kubernetes Cluster. According to this documentation, we have two distributions. The first distribution is the leaflet JupyterHub, which is for users from 1 to 100. And if you have more users, you can go for the second option, which is 0 to JupyterHub with Kubernetes. So I'm going to be focused on this today. This version of distribution is very supported by the Kubernetes cluster, which is hosted on cloud platform. So these are basically the available options, right? For learning and development purpose, you have the Kubernetes on Minikube or Kubernetes on Docker desktop, right? This for cloud hosted Kubernetes cluster. I'm going to be using the second option. I have Docker desktop installed already. I don't have a lot of money to host my Kubernetes cluster on cloud, so I'm just going to go with this option, right? So this is the instructions that have to be followed to get JupyterHub installed. So the Helm chart for JupyterHub is the recommended way according to this documentation, but there are other ways, right? Or I'm going to stick with the Helm chart. So the Helm chart actually make things easier for you with just a few commands. You can get Kubernetes, JupyterHub set up on your Kubernetes cluster. I'm just going to run the command and install JupyterHub. There are some other configurations that have to be done, like the proxy configurations, load balancer, and ingress, and some other configurations. If you used Kubernetes to deploy applications previously, you know about all these configurations I'm talking about. So, but I'm just going to go with a simple instruction just to get JupyterHub set up, and that is it. Right, so let's get started. The first thing you need to have is basically your Kubernetes cluster. As I said, I'm going to be using Docker desktop, and Kubernetes is running on the Docker desktop. So just to prove that, let me type kubectl get ports. This should show me the list of running ports on my Kubernetes cluster. So if you are going to use Helm to install JupyterHub, you need to have Helm installed on your Kubernetes cluster first. And there are instructions on how to install Helms. So if I go back to the previous documentation, there should be setting up Helm here. So if you go through this, you will see the command to install Helm on your system, right, where the Kubernetes cluster is set up, right? So once you've got Helm installed, you can confirm the version based on this. I tried to install Helm on my window, right, but it didn't work. What I did was basically go through this documentation for the different ways of installing Helm. So if I go down a bit, so I'll use winget to install Helm instead of using the call command. So this basically allow me to install him. Let me just run the command again. So it's a winget install dot so it's a found existing package already installed. So now I know Helm is installed, right? I just need to go ahead with the rest of the steps. I've got a notebook here where I've got all the steps written down. So, um, assuming you have Kubernetes running and you've got Helm installed, the step one is the next instruction you need to follow. And what this instruction says is to make Helm aware of JupyterHub Helm Chart Repository, right? So there is a JupyterHub Helm Chart Repository. So you need to add the JupyterHub Helm Chart Repository to the Helm repo, right? So all you need to do is run this command, Helm repo add JupyterHub. The instructions are here. So if I go back a bit, so this is the first instruction to basically add JupyterHub Helm chart to the Helm repo. So I'm going to run this now. The command is Helm repo add. I'm just going to copy and paste the Helm chart URL. So Helm repo add the JupyterHub. Okay, so this JupyterHub Helm chart has been added. So the next thing I'm going to do is update the Helm repo so it knows that a new repo has been added. Okay, now that is done, right? We kind of see almost the same thing here, right? So the next thing is to run this command to install JupyterHub based on the JupyterHub Helm chart, basically. Okay. So now the command to install JupyterHub is this. So it's helm upgrade clean up fill install JupyterHub. So this JupyterHub here is the release. If you see this documentation, this is the release name, the Helm release name, and this is just like the JupyterHub Helm chart repo. So that'll be JupyterHub was like JupyterHub. Then the namespace is going to be JupyterHub. You can give it any namespace just to remember the namespace of the application you're trying to run in on the Kubernetes cluster. Okay, JupyterHub, and the namespace hasn't been created, so I'm just going to give this command to create it. If you want, you can create the namespace before running this command, then you don't have to specify the create namespace. So the version I'm going to run, or the version of the Helm chart I'm going to use to install JupyterHub is going to be 3.3.0. You can go for any versions, right? I think the latest version is 4.1.0. So the values is going to be config.yaml. Now, if you go back to this documentation, right, um, the config.yaml is the configuration file. So the Helm chart already have the configurations that basically allow JupyterHub to be installed, right? But if you want to, those are default configuration. So the config.yaml is where you can provide your custom configuration, right? So for now, I'm just going to have a comment there. I'm not going to and put any configuration there, right? So I've created this JupyterHub folder here. I'm just going to open it here and create a file called config.yaml, right? So what I'm going to do here is just paste the um, basically have the default comment from here there. So it's not going to be doing anything. It's just a way to provide the custom config file for the installation. So the value is config.yaml, right? So if I run this, it should hopefully, no, it doesn't install. Okay, so I've made a mistake somewhere here. It should be create-namespace. So now the installation is done. If I scroll back up, it shows me that the installation is completed. Now to confirm that JupyterHub is set up in my Kubernetes cluster, what I would do is run kubectl get pod and get me the running pod, right, on the um, Kubernetes resources here. Well, if I specify the namespace, if I say namespace is JupyterHub, it will get me the JupyterHub pod, right? So this is specific to JupyterHub. Now you can see these are the um, JupyterHub running pod. So this is proxy pod, the user scheduler, and so on. And if I check SVC, which is the service, right, it should show me that um, the proxy public is available. At the moment, it's not providing any external IP, right? It shows pending. So let me check that again. So that is the pending. I want to show you JupyterHub UI, but as you can see here, it's showing me that the proxy public load balancer external IP is in pending state. So let me try localhost. So I think I've got another applications that is using localhost, right? Um, if I check my if I use kubectl get SVC, right, without the JupyterHub namespace. So you can see um, this SVC PSLB is running a localhost. I don't need it for now. What I can do just for this case of um, demo, right? I can just remove that one. So if I run kubectl delete pod, so it's a service, right? Delete service, and the service name is this PS-LB, right? Okay, so if I run localhost again, it's showing. Okay, that is gone right. So what I will try to do is now check. Okay, now you see it's automatically transferred to JupyterHub, right? And it shows me this login page, right? So now the localhost um, was attached to the PSLB, right, before, but now it's got attached to the JupyterHub proxy public, which is this one. If I run that again, um, you see now it's got out of pending state and it's got localhost as the external IP. If you are working in a Kubernetes cluster hosted in cloud, an IP, an actual IP will be provided rather than the external IP, and you can actually configure your load balancer to use a static IP, right? Well, yeah, that is out of the scope of this tutorial. But now you've got the JupyterHub login page. But one thing I want to show you is the default configuration file. So following these um, steps, right, I'm just going to copy and paste this command, right? And what this command does is basically it's going to show you the actual values.yaml file, which the Helm chart is used to install JupyterHub, right? So, and I'm going to write the output to the values.yaml file, right? Okay, that is done. If I do so I've got values.yaml file. So if I go back to my VS Code, just expand it, right? And I should have the values.yaml file here. So these are the configurations that were used to set up the JupyterHub. So, but what I want to do here is copy everything here. For the purpose of this tutorial, I'm just going to have everything here and start editing. So what I want to edit first is the secret token. Okay, secret token. And the secret token is going to be used by proxy to authorize access to the proxy JupyterHub, kind of a way of, for proxy to uniquely identify the token and grant access, right, for the JupyterHub. Now, but you can read on it. So how I'm going to get the token is by running this command, openssl round hex 32. So that will generate the hex string for me. So I've got the string here. What I'll do is copy it and provide it here. You can see these are all the configurations that you can edit and update to your likings, right? And so another thing I want to show you is the PVC, right? So the PVC, which is the persistent volume claim. So each user that log into the JupyterHub is going to get this amount of capacity, right? So you can configure it the way you want, right? So I'm going to save this and just upgrade the Helm chart again. And to do that, I have to run this command, which I've already put here. So when you're upgrading, don't forget to provide the namespace, which is the JupyterHub, and provide the version because there are different versions of the Helm chart. So you specify the version that you're working with. So if I run this, um, issue updates the JupyterHub, right? Okay, cool. So now I'll go to the, let me refresh. So I can log in as Stephen, provide some random password, enter. If everything goes well, I should get the Jupyter notebook. There you go. So I can create whatever I want to create. This is the Python kernel, right? This is the notebook. I can run any Python command. You can save this. You can save this, and if you log out, right? If you log out here, go to file and click on log out. But before you log out, you can go to hub control panel, stop my server. So um, I wanted to show you something before I stop the server. I'll start the server again. What I want to show you is the kubectl get pod command. Namespace is JupyterHub. You can see here it's created a new Jupyter notebook, kind of the UI, right? It's created a new pod for my user. Say, let's say another user login, right? Let me open this in a private window. Let's say assuming another user login, right? So let's say Isaac login, right? Isaac login. You get it, password, right? So if I go to if I check the pod again, a new pod should have been created for Isaac user, right? So Jupyter Isaac, Jupyter statement. So Isaac can create another file here, print for modules 2. Okay, Isaac can create save his own file here. So now let Stephen log out, right? If Stephen log out, Stephen stop the server, right? After Stephen stop the server, let's check the pod again, right? The pod is still running, right? You can see the pod now Stephen pod has gone away, right? Stephen pod has gone away because Stephen has stopped the server, right? And but James Isaac pod is still there. So now let's log back. Let's start Stephen server again because there is a persistence volume claim, right? The Stephen content should be there. You see, this when the server gets stopped, right? The pod got deleted, but the content remains, and that is because the pod of each user has a specific persistent volume claim, which I showed you here. And I can show you on the UI as well by running kubectl get pvc. So the command is kubectl get pvc pvc and I need to specify the namespace with the JupyterHub. So this is not looking good. Let me enlarge. Okay. So you can see here, Isaac claim is 10 GI, which is the capacity. And that's because that is why the content of Isaac or Stephen notebook remains, even if you got rid of the server or pod in which the notebook is running. But the content will still be there as soon as there is enough space. So that is just the setup in nutshell. Nutshell. Yeah, that is it. Thank you for watching. Don't forget to hit the like button, the subscribe button, and leave a comment. Have a lovely day and goodbye.